Artificial intelligence uses current knowledge on how the brain works to make electronic systems function like a human. Artificial intelligence uses a biological understanding of neuroscience in which neurons act like receptors, which then transmit electrical signals to all your nerves, which are then interpreted by the brain. In the brain, the neocortex, or neural cortex, controls all of the learning. Artificial intelligence mimics this neocortex to maximize computing power. This is implemented in a more recent example such as IBM's Watson, which uses many hard drives that emulate these neocortices and are all connected to a central terminal drive that interprets the information that is given by the hard drives. This is most similar to the processes of the brain.
Language is an area where, from the very beginning of the computer era, people kept expecting computers to do reasonably well at. They expected computers could talk. They could understand what it is you're asking for, and then they can do that thing, or they can answer that thing. And so far, the computers have failed to deliver on this promise.
There's something called open question answering that has been a problem in computer science from the beginning. It's much more difficult than search. It's not about a single keyword. It's much more the way normal humans communicate.
Humans communicate very fluently in images, in literature, in writing. People get natural language because it's a human artifact. They relate those words and those phrases and those ideas back to the way they think. They ground that information in human cognition and their human experience. But that's not written in a formal database language or a formal mathematical language that computers can understand.
Computers are used to unambiguous things. Human language, completely the opposite. Last night, I shot an elephant in my pajamas. How it got in my pajamas, I'll never know. We know what the pajamas are modifying, but the computer, it's just as likely that the elephant's wearing pajamas.
And that's where computers struggle dramatically, and that's where we want to make them better. IBM executives were really interested in doing sort of the next big grand challenge, the next deep blue.
Do you have any questions before we begin? Everything's going to work pretty much exactly the same way it did for you on the show. The only difference is we do not have a time limit, so we will play.
I had heard some rumblings about maybe we would take a look at doing question answering on a big scale. And maybe we would look at doing something that could take on a real challenge, like Jeopardy!
Deep search and deep analytics was becoming a tougher and tougher problem for general purpose computers. So we said, well, let's build a specialized computer to do this and do it at an incredibly fast rate.
Let's take a look at our categories. Philosophic ideas, Bergopolis.
Ultimately, we're not playing Jeopardy! What we're trying to do is make computers better at processing all that natural language content. Can you imagine computers communicating more fluently in natural language?
In 1778, this man, the Elder, suffered a fatal collapse minutes after speaking against colonial independence. Watson. Who is William Pitt? That is correct. Watson wins the game.
It is irresistible to pursue this, because as we pursue understanding natural language, we pursue the heart of what we think of when we think of human intelligence.
Another important understanding of the brain is that the dendrites within and around your body cannot touch each other, or else there will be a nerve pinch. This plays essential because if two different hard drives within IBM's Watson had run together, even though the information was on different partitions, the information would have been corrupted by the overlapping of functions and computations. Medical technologies have also advanced through the use of artificial intelligence in the form of robots. GE is currently working on systems for surgical imaging that allows for more accurate scans of tumors and critical bodily systems. Another use of artificial intelligence is automated surgery. Medical operations such as checking blood arteries are conducted by advanced robots injected into the blood. All this advancement in technology has been made possible by the increasing amount of computing power that is becoming available. Ray Kurzweil, a futurist, has said, quote, AI is currently fueling technology for an exponential progression, end quote. This means that the rate at which computers are getting faster is an exponential function that isn't destined to level off anytime soon. Moore's law depicts that technology will reach a singularity in time, the year when a computer is esteemed to be smarter than a human. This year is estimated to be 2045, the year of the singularity. Ray Kurzweil wrote about this event, which was published in Time magazine under the title, The Year When Man Becomes Immortal.
You'll hear people say, well, we can't predict the future. And if you ask me, will the price of Google be higher or lower than it is today 3 years from now, that's very hard to say. But if you ask me what will it cost for 1 MIPS of computing in 2010, or the cost to sequence a base pair of DNA in 2012, those are very predictable. There are remarkably smooth exponential curves that govern price, performance, capacity, but there's really a theoretical reason why technology develops in an exponential fashion. The Genome Project was a controversial project in 1990. We had our best PhD students, our most advanced equipment around the world. We got 1/10,000th of the project done. But it's the nature of exponential growth that once it reaches the knee of the curve, it explodes. Most of the project was done in the last few years of the project. It took us 15 years to sequence HIV. We sequenced SARS in 31 days. Now, this is an interesting chart, and this really gets at the fundamental reason why an evolutionary process, and both biology and technology are evolutionary processes, accelerate. They work through indirection. They create a capability, and then it uses that capability to bring on the next stage. So the first step in biological evolution, the evolution of DNA, actually it was RNA came first, took billions of years. But then evolution used that information processing backbone to bring on the next stage. So the Cambrian explosion, when all the body plans of the animals were evolved, took only 10 million years. It was 200 times faster. And then working through indirection, evolution used essentially the technology creating species to bring on the next stage, which were the first steps in technological evolution. The first step took tens of thousands of years. Stone tools, fire, the wheel, kept accelerating. We always used then the latest generation of technology to create the next generation. Information technologies doubled their capacity, price, performance, bandwidth every year. My main message is that progress in technology is exponential, not linear. Many, even scientists, assume a linear model. So they'll say, oh, it'll be hundreds of years before we have self-replicating nanotechnology assembly or artificial intelligence. If you really look at the power of exponential growth, you'll see that these things are pretty soon at hand.
As the computing power of computers increases, the demand for new artificial intelligence applications and research keeps growing.